Hello guys, a warm welcome to Apex AI Champs Lab. Uh, as per my promise, I am creating a playlist for all the essential C++ concepts, and here we have listed 5 C++ concepts that you must know to unlock data structures and algorithms. First concept is C++ pointers, new and delete operator. Second concept, C++ functions, very important, classes and objects. Again, it is very important, you can say, constructors and destructors, use of this pointer. So let's not waste time. We'll start with C++ pointers. So in our approach, always we'll have a real life examples, then the concept, coding, and then the program outputs we'll check. So this is how we'll proceed. We'll start with C++ pointers. So आपको पता है कि जब भी आप पानी पीना चाहते हैं तो you look for what? You look for a glass, because the standard convention or the standard thing is that whenever we feel like thirsty and we want to drink water, we use glass at home. And then similarly, if you want to enjoy a cup of coffee, then there is a coffee cup. You can see here in the slide, it is shown here. Say this is a glass. This is a glass. It's a container for water. And this is a coffee cup. That's a container for coffee. And this is a container for tea. It's a teacup. You can see here the images. So then what exactly these containers are doing? These containers are helping us to hold something, or you can say store something. So we have some exclusive containers. Whenever I feel thirsty, if there is a glass at home, I'll never look for a cup. I'll never look for a cup to drink water, because for drinking water I use glass. Similarly, if I want to drink tea, then I search for a cup, because cup is a container for tea. Glass is a container for water. The same way in programming as well, when we store values, they use containers. Those containers are nothing but we call it as variables. Now, what is a pointer? Why we are talking about a variable? Pointer is a special variable. You can see pointer is a special variable. Why we call it as a special? Because it holds or stores address. Address is a special value. The compiler or the system treats this as a special value. It will not be like our ordinary data, ordinary values. Say if I want X, what is X? 125. What is salary? Salary is a variable. What is salary? 92,000. So these values, these are our decimal values, floating point values. We treat them as data. But when we talk about a pointer, it represents a special value that is called as address. So every variable in program has address. Every variable has address. Why? When a variable is created, when a variable is declared, it creates a space in the memory. So if I say int x, so this declaration, this statement, when it gets compiled, it allocates memory, and the amount of memory depends on the type of data. Like integer, normally we use 4 bytes. Windows Linux uses 4 bytes. So here you will be storing some integer value, say 5. So when you allocate, the system assigns to this location some address. That addresses are actually hexadecimal. 1, 2, A, E. This way, the addresses are hexadecimal. 1 byte, 1 address it will be. Now here we have 4 bytes, 4 addresses will be there. So the address of the first byte of the location will be treated as address of that variable. So how to create a variable to store these addresses? That is our next question, next agenda. So C++ creates pointer variables using following syntax. So the syntax is what? You need to make use of a data type. Data type will be there and pointer name. Say similarly, we can make use of say int star. It's a data type. Float star. It's a data type. So it is an integer pointer. It is a float pointer. Similarly, I have created a double pointer, character pointer. The interesting point here is that regardless of the pointer type, the amount of memory allocated is same to all the types. Say here it is an integer, 4 bytes of memory is allocated. It's a 4 bytes is allocated. If it is a character pointer, char star, what is the amount of memory allocated to it? It's 4 bytes only because addresses are 4 bytes long. Whether it is the address of a character, whether it's the address of a double, say I'm storing address of a double. Again, this is also 4 bytes. So normally it is the size of an integer on that machine, Windows 4 bytes, Linux 4 bytes. So that's what my next point is there here. Normally the size of pointer is the size of integer on machine. For example, for Windows, Linux, as the size of integer is 4 bytes, the amount of memory allocated is 4 bytes. Now, once we create a container for address, we can store address in it. Let's do some brainstorming now. So, is it coming to your mind why we need to store addresses? Why we need to worry about the addresses? Say you have a Java, Python, there you don't worry about these addresses. But when you come to C and C++, the concept called pointer comes into picture, and that is what addresses. Why we need to use addresses? That's the question. So that we'll answer in our future sessions, why it is required. Actually, in one one or two statements, I'll just give you a hint. When we use functions in C, C++, functions manipulate data. So when they manipulate more than one value, more than one variable, it is not possible to reflect all through return statement. In that case, what we do, all the variables which are getting modified, if we send their addresses, and using that address, if we manipulate, automatically the changes will be reflected. So in detail, I'll demonstrate with example later when we visit functions. Now let's store address of one variable and manipulate value held in that one. How we do that? For that, the language provides two operators called address of operator and value at operator. So this we call ampersand. It's an address of operator and address of. And this is asterisk. This we call it as value at address. So how we read it? Value at address. Now we have already created a pointer. Say this is a variable integer age. Say this is a variable age. And we'll assume a decimal address for our explanation. Say the address is 650 and the variable is age. Say how much, some value if you want, you can initialize in it. And then you will create another variable. This is a special variable, that is pointer, integer pointer. Again, it has also some address, say 8660, some address it could be. And but again, its size is 4 bytes. I told you already in the beginning. So any type of pointer you take, it has the size of integer as a address, the number of bytes allocated to it. Now, when I say if I want to store in this address of age, so how I do? In ptr I'll store address of age. So this is the address of operator through which use we obtain address. So to access to access or modify the value, once I stored it, now if I want to modify it, or access it, for that value at address will be there. So value at PTR, it means it refers to this age. You can say if PTR is pointing to age, then value at PTR is nothing but the variable age, provided PTR should point or PTR should hold address of variable age. So this is how let's try one program here. Let's see one program. Just a moment. Here we have one program. Look at this program. Go through this. What we did in the earlier stage, we declared variable and pointer variable we created, and we initialized the variable. Then we are manipulating value of this age using this pointer. So I'll illustrate this with the help of diagram. Say this is the variable age, and in age we have 18. Let's say its arbitrary address is 6500, and I created a pointer. Let's say its address is 6780. What you are doing now in this pointer, this statement is important for us here. We missed this statement here. In PTR, we have to put the age, address of age here, like this. Here in PTR, we have to put the address of age. So what is the address of age? This is 6550. Now when you say value at PTR, what is PTR actually? PTR is 6550, not 6780. 6780 is the address of PTR. So what is PTR? 6550. So value at address 6550 will be modified now, 21. So at location 6550 it will go and modify the value. Then when you say cout age, so what is the output? Can you guess? It is 21. It is modified. So this is how pointers are used to manipulate value of variables using their addresses. Now let's reinforce all the concepts what we discussed now. What is the size of a pointer? What is the size of a pointer? I told you it is regardless of the type of pointer, it is always 4 bytes. It is 4 bytes. 4 bytes. Then what if I declare float star PTR as a float pointer, then what is the type of address allocated to the pointer? So whether you are storing address of a floating point number, character, whatever it is, all addresses are unsigned integers. That is positive integers, positive numbers. So second question is answered. Now let's take third. Double star P. So I am creating a double pointer DP. How much memory is allocated to DP? The amount of memory allocated to DP is not 8 bytes. It is not 8 bytes because we are not allocating memory for a double variable. We are allocating memory for a pointer. So again the same statement. Regardless of the type of pointer, the amount of memory allocated to any pointer is 4 bytes. Then find output. Let's find output of this one. This is interesting. What is the output here? Let's analyze the program. Say I is a variable with value 5. Let's say its arbitrary address is 6500. Then again another pointer variable I have created, pointer, let's say its address is 76. Then in this PTR I am storing address of I. So 6550 will come here now. This is the statement. Because of this statement I am storing address of I in PTR. Now what he has said, cout I plus plus, cout I. It is a postfix. Present value of I will be, current value is 5. That will be displayed, and then I value gets incremented in memory. Now if I say cout value at PTR, what is PTR? In PTR I have 6550 and value at 6550, now it is 6. So the output will be value at PTR. Though you are displaying value of I, initially it was 5, but later it got modified and that output is 6. I hope you are getting it. Let's go for the next example. Last example, we'll go for it. See here again we'll have a similar kind, but I am doing initialization of a variable through its address. Say there is a variable I and there is a variable j. Let's say its address is 6550. Arbitrary addresses, don't take them as real actual addresses. Then I have PTR. Address of j I'll be putting in PTR, that is 6550. Then initialized I, you already initialized to 5. What you are saying now? Value at PTR. PTR is what? 6550. So that is pointing to J. 6550 is the address of J. So that will be I plus plus. So it is a postfix. Current value will go. Current value of I will go, and then I will get incremented to 6. Then when you display I got incremented to 6 and J was initialized to 5 using its address. I never initialized here in the program J equal to anywhere, but I did it through this value at PTR. So hope the concept of pointer basic, it is a basic. In the next session I will discuss more advanced and we'll have some hands-on with some online compiler as well. Thank you so much for watching. Thank you.